Hello class, we're doing Module 8, Chapter 11, the over correlation and regression, the Pearson and the Spearman correlations. And our course project will be presenting data and providing an analysis of some of that data. We'll start out with the correlation and regression statistic. Correlation and regression show the relationship between two continuous variables. And here's an example. An instructor wants to discover if there's a correlation between the length of time spent taking an exam and the grade on that exam. The instructor gathers two pieces of data for each student, minutes spent taking an exam and the grade on the exam. And here's their data. Not all of it, but here's what it looks like on a graph. Time on this axis. The dependent variable is the grade based on time, so we put the dependent variable on the y-axis. We plot all the data, and actually the computer will plot it for us, but when we were in high school, we drew this line with a ruler to find the best straight line through our data. I think you might recall that. Then there's a slope to that line. We would have to find I think in your science classes, if you did this, you did college algebra, you had to find the slope of this line, and you needed the rise over the run. You remember those kinds of things. Here's a hypothesis. There is no correlation between the length of time spent taking the exam and the grade on the exam, and H1 here, the motivated hypothesis. Let's see. In this chapter, we're going to use either the Pearson or the Spearman. I'll tell you now, the Pearson is used for continuous variables that pass three specific test, pre-test situations, pretty much like all those we've checked data for before. The Spearman is good for categorical data, and it's good for those data that are continuous that are not normal and do not solve the test of the Pearson. The Pearson is the most commonly used form of the test, and anytime anyone uses the word correlation, they're probably speaking of the Pearson. Okay, we're going to determine the relationship between two variables, and we're going to be calculating a correlation value, and that value is always between -1 and +1. The strength is called the R value, so the R value falls between -1 and 1. How steep the graph is doesn't have anything to do with it, or what direction it's going in does not have anything to do with it. We always just take the absolute value of it and talk about the magnitude of the strength. This one has a strength of 0.8 on a scale we'll talk about in a moment. The signs plus and minus indicate the direction of the graph, and the correlation ranges between -1 and +1. You can have a strong negative correlation and a strong positive correlation. Again, we take the absolute value and talk about it in terms of 0 to 1, where the weak value is the weakest would be 0 and the strongest would be +1 or -1. Here's that graph again. And the regression line, this line that you draw through there, is the average pathway through the points. It's the one line that is closest to all the points of the data. Here are some examples of a strong correlation because all the dots are on the line. Here's a negative correlation, but that doesn't mean anything. The strength is still pretty good. I'd classify that at about a 0.6. Here's about a 0.8 correlation. It's positive because all the dots are much closer to the line. This one, probably about a 2.2. Okay, let's talk about the strength. And when we mention strength, we might say it's a weak correlation. We will if the absolute value of the correlation, the R value, is less than 0.3. We will say that it is moderate if it is between 0.3 and 0.7, and we will say it is strong if it is greater than 0.7. And we're going to talk about a lot of correlations, and they all follow this same rule. Here is a strong positive correlation. You can see all the dots are very close to the line. They say this one's weak. I wouldn't say it's that weak. It's a weak one. This is a strong negative correlation because it's pointed downward. This is a weak to moderate, I would think, pointed downward, sloping downward. And this is a moderate. They call this one moderate. And this one is no correlation at all. Do not get correlation confused with causation. You can't not say because you have a correlation that it was the cause of something. Do not put the word cause in any of your hypotheses. Do not talk about cause in your dissertation. No, that's out. Spearman correlation. It's called rho. The value, instead of the R value, it's the rho value. It works the same way as between -1 and +1. And those terms we used to describe that a moment ago still hold for this. Weak, moderate, and strong. Here's an example, because this is categorical data. Here's Alice's preference for ice cream and Bill's, and they're identical. So that correlation is probably a 1. Well, it is. The Spearman rho is a 1. Here's a correlation of the opposite type. They're just the opposite of each other. They're reverse of one another. So this is going to be a -1 correlation. It's still as strong as this one. It's just in the different direction. Here's a correlation where Alice likes chocolate, strawberry, and vanilla. Bill likes chocolate, vanilla, and strawberry. And if you look at this thing, they're together on type, and then these two are not so much. And this turns out to be a 0.667 and an R scale. That would be a moderate. That'd be a moderate correlation. Here's an example of a dietitian has a patient to arrange 5 cards in order of preference with the most favorite food at the top. The dietitian will then use another set of cards to show the recommended diet for that person. Then the dietitian will record the 2 card sequences, patient, dietitian, and compare them using the Spearman's rho. Here it is. There is no correlation between the dietitian's recommended food ranking and the patient's food preferences. Here they are. Vegetables on top, pork on bottom, fish on top. Let's see what happens. On the SPSS software, the test is run, and the rho is 0.9. The p-value of that is 0.037, so it's significant, below the 0.05 level. It indicates a statistically significant, strong positive correlation. So you use those words when you talk about this. Here's what the output looks like, and this looks the same way, similarly for the Pearson. So we reject the null hypothesis and accept the motivated hypothesis. Let's talk about the course project, because you can watch those 5 videos on those analyses, and you'll find out exactly how to do the 3 homework problems on the Pearson and Spearman values. Here's what you're going to do. You're going to make your first attempt at analyzing one of your hypotheses for your study. And you will use your fictitious data from the last assignment, unless as you go through this you find out you need to change that fictitious data. And that's what this is. This is a dress rehearsal. You can change what you will. When you get to the real data, you can't change anything. You're going to present a data table, descriptive statistics for the table, a research question you're going to solve, the hypothesis you're going to solve, you're going to discuss the statistics that you chose. You can use Cronk for that. Whatever you chose, you can look in there and find what you need. Present SPSS tables that were generated, and the reason I ask you to present those is because we're not ready to make all of them an APA style. You will do the descriptives. The instructions I give you have exemplars that you can look all this stuff up. We'll look at it later. And then you're going to write an abstract of what you have. Let's go ahead and look at this. These are the instructions with the exemplars that you can access at the site at the end of the opening site here. You're going to present a data table. That's the first thing you're going to do. And if it's a very long, and you're going to do this, call it your appendix, because you don't normally put the data itself, very seldom, in the text in chapter 4. It's in the appendix. So you call your data, whatever it is, an appendix, and put it at the end of what we do in this homework. Then you're going to present a descriptive analysis. You can do this with most data, except the kind of data that you would do a chi-square with. It's difficult to do that. And if you have trouble presenting that data, you can present some tables. Your chi-square table, a contingency table of the getting ready for the chi-square, that's one form. And then you can present percent values with it. You're going to present your research question, and here's an example of what you might print. This one is there a difference in performance of boys and girls on the 9th grade administration of the Hinman-Nelson test of intelligence among schools of Craighead County during the fall of 2018? And then, of course, there's the hypothesis. There is no significant. and it's the same thing. You just redo that part of it. Then you're going to make a statement about the type of statistic you chose to resolve your hypothesis. And you can find that information in Cronk. Here's an example of what I did for the t-test and why I chose it for this. You can look at that kind of thing in later. You're going to present your SPSS tables generated for your hypothesis test. Here's table 1. Notice the italic print above the table. You do that. And this is not in APA format. And it should not be because I asked you not to. But in the real thing, you will put this in APA format. So here's an n value, mean, standard deviation, standard error. If you're doing a chi-square, present your first chi-square contingency table. T-test, here's the results of the t-test. You just put that in there. Table 2, t-test statistics for mean, Hinman, Nelson. Then you're going to write a response for the statistical test. Guess what that is? That's an abstract. So you just follow the rules for an abstract. Now here's what you're going to do to get your homework accomplished, the week's work. There are 5 videos. Watch those 5 videos and they will show you exactly how to solve each of these 3 problems. 11.2a, 11.8, and 11.10a. That's 11.8b. So do that. And then the course project. Let's talk a little more about that. Here you're going to do the course project and analyze your data. And it tells you again what you do. You'll get a set of instructions at the top. Right here's the, if you hit that, that'll show you the exemplars that you need to have to do this assignment. Let me talk about a couple things here. Presenting research questions and hypotheses. If you are going to use 2 different statistics, then you will have to present both of those. If you're going to only use one statistic like the chi-square or the t-test, then you just have one hypothesis, one research question, and so on. If you're going to do 2 different statistical tests, you will have 2 hypotheses to test and 2 research questions. Then on number 6, it says present. Now look at this. It says present the SPSS tables that were generated for the hypothesis test. Let's just say that for some reason you can't figure out how to do the test or run the test. It's not one that we've done yet. Here's what you do. Have some instructions down here at the bottom, and I'll show you these on the next sheet. Next slide. A special note for completing step 6 above the course project. If you are unsure about how to run the test you have selected for determining the significance of the relationship in your data, you can punt. In other words, you can go either to Cronk or Knapp and find the type of statistical test you think you might have chosen and make fake output tables. The author's representation of their example. They will have an example, Cronk does, and you can just look at it and make your own, to represent your already fake data. And then you use their format and language of the interpretation to write your abstract. It's all there in Cronk. If you can't do it, if you can't figure it out, what this is a dress rehearsal. I put that comment down there for the real thing. So like they've told me, Hux, if you can't be it, look it anyway. Just look like it. So that's what we're going to do here. We're practicing. You're going to get some more practice on how to do this. So good luck.